Hey everybody, welcome to episode 6 of the Mobilecast. We have a great episode for you today, and we're actually coming to you from our makeshift studio in the Presidential Suite at the Hyatt Regency in Boston. I happen to be on a panel later today at the Wi-Fi and Small Cell North American Conference, and I actually have the pleasure of sitting here with Art King, who's been a friend of mine for a while. He used to be at Nike. He's now at a company called Spidercloud. And we're going to be talking about Wi-Fi, small cells, and how it relates to mobile. So, Art, why don't you introduce yourself?
Greetings. Art King with Spidercloud. I am a marketing person, used to be an engineer, and it's been a grand adventure kind of representing the consumer experience to our customers who are mobile operators. You wouldn't be surprised to know how many of our customers don't have a consciousness around the problems that are being faced inside the enterprise.
It doesn't surprise me because you have a similar job at Nike that I have now. Yeah. What did you actually do at Nike so people understand where you're coming from before you went to Spidercloud?
I did global mobility, roaming, networking, wireless LAN, a ton of different things, but in the last few years of my tenure, there was a deep focus on mobile and adopting something, so we had an infrastructure platform such that our dev organization had a place to launch applications off against and do more to service the business inside. And internally, I was also working with a number of operators and a number of different vendors to improve the customer experience, improve services to the organization, and to provide a lot of blanket wireless coverage everywhere so I could mobilize the enterprise and remove fixed assets off the desktop, remove software out of laptops. Really, our strategic plan was blocked by the lack of good cellular service within our buildings.
So you left Nike about a year ago, if I remember correctly.
Yes.
You went to Spidercloud expressly to solve the issue that, quite honestly, we all have in the enterprise. As much as people like to say it, networking is not ubiquitous. Voice data, you can be in places, we're in a hotel right now and we have good coverage in this room, but there are parts of this hotel where you get absolutely nothing.
Right.
So let's start simply. Tell me what small cell wireless really is.
Small cell wireless is an economical way to bring service, inside a building. The larger definition of small cells includes metro cells and picocells, which are more outdoor technologies. But Spidercloud, our focus is indoors in buildings above about 25,000 square feet. So, small cells, if you look at things like Ubiquitous, which was a recent Cisco acquisition, they cover probably up to about a 25,000 square foot building, and above that, the engineering gets really daunting to coordinate a lot of those, the standalone small cells.
So when you're talking about small cells, you mentioned picocells and microcells. Mm-hmm. Are we essentially talking what I would know as a femtocell? Basically, here's a way to bring wireless into my house because I have AT&T, Verizon, Sprint, T-Mobile, and I'm in an area that has lousy coverage, but I have an internet. I have a very good internet bandwidth, and I hook up this femtocell that gives me the ability to now answer my phone rings, I can do data over it. Is that what we're talking about essentially?
Absolutely, yeah. The small cell, I think, is characterized slightly different from the femtocell in that it can scale up, quite significantly. The femtocells were designed as a coverage play to provide service in areas that had no signal at all. And we provide a technology that allows you to have many femtocells inside a building and coordinate and walk amongst them. If you rewind to 10 years ago, enterprise Wi-Fi was a disaster 10 years ago. It was extremely hard to manage with all the fat APs and all the SSIDs you'd have to configure and the lack of tools. It was just a huge mess. And Airspace, Aruba, Trapeze. They innovated a controller-based architecture that orchestrated the activities of all the APs inside the infrastructure in such a way that, you and I as enterprise guys could deploy it and live to tell about it.
Yeah, I mean, essentially we could take our we're talking 10 years ago, we could take our laptop, I can move from one side of my building to the other side of my building and have a signal the whole way because I moved between access points and I had a nice soft transfer that allowed my data to keep roaming, assuming it was a good day.
Right.
Let's be fair, we're talking 10 years ago, we still had our hiccups. We still have some of those today. I think that one of the biggest, we're going to talk scenarios later, but, one of the biggest hiccups I see is that it's bandwidth utilization. We have access points where we're great, then from around 11 o'clock to 1:30 as people start doing lunch and everything else and hitting everything on their mobile devices, all of a sudden bandwidth goes from, hey, I was doing this to I can barely pull up a web page. And so it becomes interesting.
Yeah, absolutely. The wholesale, re-implementation of a controller-based architecture with small cells for licensed spectrum, we basically looked at what was done 10 years ago and said that's exactly what's needed to bring wireless licensed spectrum inside a building so the cell phones work correctly.
So let's go. Let's talk about Spidercloud for a second. Mm-hmm. What's the secret sauce that Spidercloud actually brings to this? Because you mentioned that there are a bunch of Ubiquitous,
yes,
which was bought by Cisco, and I apologize, it's a tongue twister sometimes. Handles up to 25,000 square feet.
Yeah.
You handle above that, but where's that? What's the secret sauce that's in there?
Really smart engineers on our side. The work to do soft handover on 3G. So 3G spectrum is a reuse of one. So you have the same wireless spectrum everywhere in a market, and when you walk along and you're handed from tower to tower, you actually do a soft handover where you change a scrambler code as you're walking along, and you go to the next tower as you walk along. So it's a really soft handover is absolutely necessary for voice, because when you do a hard handover, you actually can drop calls. So it
happens all the time.
Yeah. So we our engineers figured out all the stuff necessary to do soft handover in 3G, and it's one of those things that hasn't been figured out yet by any other company, to the best of our knowledge.
So you handle 3G, all carriers. So is that, we're in the U.S., but, does it handle CDMA? Does it handle AT&T, T-Mobile, the Sprint stuff? I mean, does it matter? Although they all have different definitions of what are called 3G, so.
So 3G, we are a single operator solution. So when we go to market with our technology, an operator sells it. So it's their spectrum they're lighting up. So if it's sold by AT&T, it'll deliver service to AT&T devices. If T-Mobile sells it, it'll deliver service to their devices. We didn't do CDMA because it's about 10% of the global market. And what we're seeing is a very aggressive move to VoLTE and get voice over LTE. So with what we'll be shipping in the third quarter with LTE, we'll have that available also. So
your data is in LTE, but your data would be considered 3G. So HSPA plus speeds.
HSPA plus.
Okay. Yeah. So we're doing real well. So how does it fit in today's business, especially when we talk to the carriers, whoever it happens to be, they start with, let's put in-building repeaters in. Let's do that sort of thing. How's that fit compared to what you do? Because although they install you, there's a little bit of competition there as well. And the question becomes, how's it work? What makes sense?
Let's go back 20 years. Calpana Ethernet switches. So back in the day when there was shared Ethernet and everyone contended for that same pipe, you had major issues on your network. And Calpana came along and basically said, we're going to switch traffic only to where it's going to go and not let everyone else in the shared media see it. If you look at small cells, it's very similar. You have a very small kind of wireless domain that around the cell, just say similar to like a Wi-Fi radius, and you're pulled off the air and immediately onto a wire at that point in time.
So the advantage here is I'm not contending at the cell tower, which is, if I understand correctly, if I'm using repeaters, I'm just adding traffic to that cell tower, whereas if I'm using small cell wireless, I'm going right onto the internet backbone. I don't hit that. So in a lot of ways, it actually helps to reduce traffic for them of all those users who are in a high-capacity building.
Absolutely. It actually, the other benefit to the operators is it unloads the outdoor network because it keeps things in-house, because your phone isn't shouting through a glass-coated window to get to the tower. You also have better battery life on your phone.
Because you have a stronger signal, and then you don't have to search for it and reach so far for it. Now, I will say, knowing you well enough and knowing how old you are, I'm shocked that you only went to Ethernet and not to token ring there, but...
I can talk Type 3 media filters if we need to go there.
I'm sure you can, and yes, we do have a Terminator in the building. So this is pretty neat stuff. Now, but there's also a Wi-Fi component here. Mm-hmm. I know we kind of caught up last night, introduced you to Tuscany's ice cream over in Central Square in Cambridge. Very good ice cream if you're here in Cambridge. Sorry, been eating there forever. Definitely worth going, but we talked about there's a Wi-Fi component to small cells. How does that fit in, along with the 3G coverage and the data coverage?
So we're delivering at 802.11n, 2.5 gig and 5 gig bands, and Wi-Fi offload. So the phones get off the network. And at this point in time, 3G, as far as raw throughput, is slower than Wi-Fi. At the radio layer.
So let's ask a question there. So that makes sense. If I can Wi-Fi offload it, do you Wi-Fi offload onto the carrier's Wi-Fi, or do I integrate it, for example, into my enterprise Wi-Fi? So which access point am I looking at there when I'm doing that?
We have 16 SSIDs available, so there's carrier offload will probably be first, and maybe even guest Wi-Fi. We believe very strongly that the mobile operators need to earn the trust of the enterprise. So in the conversations that we're having with the product managers around the technology is very much, the enterprise is going to hold you at arm's length on the 802.11x secured infrastructure because there needs to be some trust building to happen. And frankly, the operational dimensions need to be figured out. Because if you're going to provide this, you need to have the whole credible support infrastructure behind it. The thing that pops to my mind on the enterprise side for the mobile operators is partnerships with people who understand ITIL and operations like ServiceNow. I see dimensions where you have to be able to have the full operations conversation. You can't come in and say, "Ta-da! I give you Wi-Fi."
Okay, so let's use that to walk right into a scenario.
Uh-huh.
I'm an enterprise. I have a campus, and I have let's say AT&T is my carrier. I'm over in Europe. I have Vodafone or I have Orange, but I don't have great signal on my campus.
Mm-hmm.
So the operator says, "Hey, we got this partnership with you guys, or we have the solution that might work for you. Let's start with one building. I have a 50,000 square foot building. I have how many people would that be? You might know that better than me.
The rule of thumb is divide by 2 in the U.S. 250 square feet per person.
Okay, so we
have 250 people.
Yeah, it should be a little bit more than that, but we have a large building. So we have a large building. We have a lot of people in it. How do we go about what are the steps to laying that out? So we start with one building. How do we install it?
So the old installation cycle was very involved. The installation cycle that you go through with Spidercloud is it's almost like a desktop design where you lay out some APs on
access points, to be clear.
Access points. We call them radio nodes, but yeah. So lay out the radio node locations on a PDF of each floor. Then you bring in a standard Wi-Fi installer or the building electrician that you use for your campus because they know all the closets and everything else. Pull in a Cat5 cable and hang the radio nodes in the ceiling and then power up the system.
Okay. So I bring my Cat5 back. Mm-hmm. Now, in most cases, do you, as an enterprise, am I running this over my own internet node? Am I making the operator bring in fiber or something else and putting it in their own switch? Who owns that? Because I think this gets back to what you're saying before when we talk about operations. Mm-hmm. If it goes down, am I responsible for it? Is the operator responsible for it? How do we figure that out? So let's start with the backhaul. Where's that usually coming from?
So in all of the European deployments we've done so far, the operator is choosing to supply the backhaul, supply the Ethernet switches, and what they request from the enterprise is 1 U of rack space in the closet and access to the dark fiber and the vertical risers.
Okay. So let's go to operations. We've installed that. We have a problem. So we were working great for the last 3 weeks. All of a sudden, my signal's down. Who do I call?
The operations support organization at the operator.
Okay.
You would not be in that business.
So the operator handles that. They come in. They're aware of it. And my guess is that's probably where some of the issues become of we need to be ready to service something like this. Because it's not our normal stuff. We're not going to the tower anymore. We're going onto somebody's campus. We're looking at the backhaul. We need to be able to decide, make sure that we're doing it right. So
guess what? That template exists. So any of the carriers that have been already doing Wi-Fi, a radio node is almost identical to a Wi-Fi node from an operations, deployment, as-built diagrams, and maintenance perspective. So any of the operators that have a fully operational Wi-Fi delivery unit, it's very easy to bolt our technology into that operations process and manage deployments with almost standard processes.
Excellent. So the question that occurred to me as we were talking about this is, what happens with my own Wi-Fi? So maybe I'm throwing Cisco access points, Aruba, whoever it happens to be, up in the ceiling. How do I manage that based upon, I have your stuff in there, I got to be careful about interference, since you're also running Wi-Fi, obviously, another thing. How do I do that plan? Does the carrier come in and do a site survey? Do they work with us to do that? How's that happen?
The carrier would have to work with you to kind of do whatever the radio planning is for the Wi-Fi. And the options are, don't turn it on. I mean, it could be that it's a dormant function that's not enabled because of whatever the concerns might be or interference issues. Turn it on and coordinate it. And we've got a lot of radio resource management, automatic channel assignment, and that kind of thing that's similar to everyone else's best practices.
Okay.
And I kind of figured that in the world that we all live in, especially on the retail side with hundreds of APs shouting at each other in malls, that all the chip makers have got a lot of this figured out just because they have to survive in retail and dense urban environments.
I would hope so, but then I walk into a mall and I discover that all the Wi-Fi just sucks.
Yeah.
So it's not the pleasant experience I would hope it would be. So that's a scenario with a single building. Now let's look at the campus. Let's say I have 6 or 7 buildings.
Right.
Is it just really the same thing except I go to a single backhaul point, or?
Yes. So if you have good fiber capacity between the buildings and or good IP connectivity, because all the radio nodes talk back to the controller over Ethernet and via IP packets. So we're very much mainstream as far as what the the backhaul and transport is for the modern world.
Now, I guess one of the questions would be, am I limited to that operator, or do we see a time in the future where I can actually run let's use the U.S. for a second. I can run T-Mobile and I can run AT&T because they're actually different frequencies, and I can get them both so that I can actually service two different populations of devices if I don't have everybody on the same operator. For example, for us in the U.S., we let people buy based upon, we limit the operators, but we let them buy based upon what their best coverage is at work and at home. Right. And where they travel, because that's important to us to make sure that, we don't give them something that, great, you're in your house and now your phone doesn't work. That's kind of, a little bit of an issue. It's the same thing in Europe. If you go to France, you have Orange, you have FSR, a bunch of other ones. You see that capability coming, although I'm not sure operators want to cooperate that way, but that's another story.
Yeah, it's certainly technologically possible. For us, the engineering half of the equation is managing power budget off of the PoE. So since we run via PoE, our engineering is very concerned about power budget as far as the number of radios, taking up all the delivery capacity of the Ethernet switch. But let's assume that power budget's not an issue. It's going to be a deeper discussion with the operators around, will you allow this? Do you want to do this? Will you run shared radio infrastructure this way? So there becomes almost a scenario where this type of thing would be similar to how the neutral host DAS guys work, where a third party runs the last mile inside the enterprise office buildings and kind of manages that last mile as far as quality and delivery.
And that would allow you to get to that sharing space.
Yeah.
So where do you see this going? Cisco's what, ubiquitous. Mm-hmm. Do you expect Cisco to just start incorporating this into their access points? Do you let's say the capability is dormant, but if you want to wire it up, you can. It's there. Where do you see, obviously you guys are working on partnerships. You guys are a slightly different level, so no proprietary stuff here. But where do you see, looking a little bit at futures, based upon, Cisco is a big boy. Mm-hmm. What do you see?
I don't know. I mean, it's unclear, how Cisco's going to incorporate things. At the Small Cell Forum at Mobile World Congress, Cisco was showing some of the kind of the strap-on piece to their APs, and it was very interesting. And downstairs we saw yesterday the Ruckus Wireless and Alcatel Lucent, two pieces that bolt together to essentially two vendors cooperating to make an outdoor infrastructure. So in the realm of partnerships and things to do, there's a ton of stuff that's going to happen. Cisco tends to acquire and build internally, so I'm not sure what their plans are. They've acquired a SON vendor, Intucell, out of Israel that did all the SON infrastructure, self-organizing networking.
Thank you. I was about to ask what SON meant. So
on the AT&T Tower network, and those guys built some brilliant software that constantly optimizes transmit power and interference amongst all the AT&T towers to really greatly improve AT&T's quality when you're outdoors.
And let's just hit that for a second, because that actually came up last night during dinner. These are the ones that allow us. Let's say I have three towers. Mm-hmm. And they overlap a little bit, but if I understood what the technology did, if I have people who are towards the outside ring or outside coverage area of one of those towers, but there are a lot of people, what the SON technology allows me to do is lower the power on that one and increase the power on an adjacent cell to kind of offload some of that traffic onto a cell that's less busy without actually having to put a new cell tower there.
Yeah.
That's pretty cool stuff.
It's brilliant. AT&T did a case study at the SON conference last October in Cannes, and they walked through it and basically said, after we optimized our network, utilization overall dropped about 40%. I mean, it was just, the numbers were massive. It was very impressive as far as the capabilities.
And once you automate it, it allows you to handle some of these edge cases, which are very, very difficult. And I know, we were downstairs this morning, and, as we're talking Wi-Fi offload, U.S. Cellular was talking about the fact that they've put out a client called Wi-Fi Now that allows automatic connection, so you don't get a pop-up page every time. If you're a customer of them, you sign on once, and then whenever you walk in range of a Wi-Fi Now access point, you automatically pop on. And what they discovered, which I thought was the best part, was that their customers that were actively using Wi-Fi Now, the Wi-Fi Now client, they saw that their cellular data bill dropped by 50%. And that's big when people are driving as much data as they actually are through the pipes. It allows you as an operator to support more people, give better service, and, we talk QoS all the time.
So the funny counterfactual in enterprise was, I was talking with a guy I worked with, and he said, there's so many people that because of our PC firewall and or all sorts of rules in the firewalls, that the iOS experience is miserable enough that people come to work and turn off Wi-Fi.
I think I was there for that conversation. And you know what? We see that everywhere. I mean, I know that we see that a little bit at work for us. We see people who will use their phone as a Wi-Fi, use their phone as a MiFi device. They'll use it to drive data. I know that if, between 11 and 1:30, our network gets slammed. Right. And this is our guest network. This is our guest network that we've designed for our iPhones and everything else so that you can go out, you can hit Facebook, Twitter, Instagram, whatever it happens to be, and, YouTube. We have a lot of that happening.
Absolutely.
And we just see that bandwidth slow to a crawl to the point that you really have to do that. And yet, I'm in a big building. I'm on a campus. We have a couple thousand people, and cellular coverage kind of falls too. It's one of those things of how do we handle that? How do we move forward? And that's part of what you're there for, essentially. That's what small cell does.
Right. And the thing is that you've got LTE, you've got 3G, you've got Wi-Fi. The way things are going with both consumption and apps and how people use things, we desperately need all that bandwidth across all those technologies to deliver the kind of customer experience that people are desiring.
Backhaul is going to become more important than any of that because you can have the best connection, and if you can't reach where you're going, it doesn't necessarily matter if you don't have that bandwidth.
Ryan, I live in a rural area. A lot of times I turn off Wi-Fi to get to a faster network signal. So I actually have to switch off Wi-Fi to get a faster connection at home. And then when I need to do app uploads or downloads and refreshes on iOS or operating system updates, even though it would be faster to do it over 4G, there's this assumption that Wi-Fi has infinite bandwidth. So I end up having to turn on Wi-Fi and then doing update on device. And
well, it is cheaper. Wi-Fi, you're on 4G, 3G, doesn't matter. You're on cellular. There is a cost to it.
Yeah.
We do not have enough unlimited these days. We've got a couple minutes left. What's coming in small cells? What's the future? You mentioned a little bit about LTE's coming, which you guys are already at the forefront with your 3G stuff, and I don't think anybody has LTE in small cells. I think that's your next step. But where do you see small cells in another year and a half, 3 years?
We have a vision of it as a service delivery platform that has a place in mobilizing the enterprise even more. The idea of clientless unified communications, where the native dialer on the cell phone, short dial strings are intercepted by our box and sent off to the PBX instead of having to route through the core and dial a full length number. So we see a lot of things around service delivery and making life better and more magic for the enterprise customers.
Now, what about, you mentioned enterprise customers, which I buy into, but we mentioned malls before and stuff like that. Are you starting to see, it's a different type of enterprise? The mall is all these little retail shops, but you add it up and you kind of get the same effect. And, having had to brave one 2 weeks ago, and one I don't go into, haven't been into in probably 20 years,
I
know how bad it can be. Do you see that there, or is that more you see other players doing that, not you guys fitting there as much?
We've had some conversations with various property owners, but sticking to our knitting around being focused on enterprise. Enterprise is a little bit easier from a business case perspective because you have an IT manager, you have a whole group of employees that are all kind of buying the same technology and or under some common programs and management.
And easier to find a budget, I'm sure. So
yeah. So the malls tend to be also very agnostic. They fit more the neutral host DAS type model because they want to improve the service for anybody that walks through.
I'm a little surprised though that you don't see operators stepping up and saying, "Hey, you know what? If I can offload it's Christmas week. Everybody, heck, I could see a point where Amazon pays the operators to go into malls to do that, so you can do your window shopping in the store and order it directly from Amazon, and a couple of years from now it'll be waiting for you. By the time you get home, it'll be delivered so quick." But
yeah, what mall?
You like to your mouth to somebody's budget.
Well, there's a whole lot of. I saw that vendor the other day who wants to charge $5 to come into the store because they're converting none of the browsers to selling. But that's a completely different.
That's a different story and a different model. I'm not sure exactly how well that model works. Okay, this has been great. I got to thank you, Art, for coming on. Taking the half hour out of your day here. I know that we have a panel that we're going to be doing in a little bit. But any last words? Any final thoughts?
Well, thanks for the time. I do monitor and listen to these podcasts also. At a personal level, enterprise is always close to my heart because I lived in it. And, we're working to try and make life better, for the actual real people that own the devices, not us.
Excellent. And Art, what's your handle on Twitter? I think it's at Art King with 2 G's, if
yes.
I'm correct. So we'll put that up in the show notes, but you can certainly follow Art at Art King with 2 G's at the end. Spidercloud Wireless is
www.spidercloud.com.
Okay. And if Art has any other things to share, we'll throw up some links onto the show notes. Thank you, everybody, for listening. This has been a heck of a lot of fun today. Art and I are old friends, so it's kind of fun to just have a conversation and figure out where things are going. And if you have comments or questions, please let us know. You can follow us on Twitter at the Mobilecast. You can reach us on thecloudcast.net as well, and post any questions, suggestions. We'd love ideas for shows you'd like to see. And let us know. And signing off till the next one.